So let's look at some designing steps that we can take with these, and how do we handle some of these spaces. So typically aisles and concourses are long and narrow. You can have different kinds of environments in aisles. It can be a finished surface in a public space, right? Walls and windows and doors and things. Or it could be actually a little bit diffuse and absorptive, like in a warehouse where packages and boxes and things actually help break up the sound a little bit, and it helps intelligibility. So that's one of the things we encounter. And then we encounter all kinds of other spaces that are part of paging systems. Concourses that can have a variety of materials, sometimes a lot of them very hard materials. This is obviously from an airport, but you can have this in shopping malls, maybe a large hotel lobby. Supermarkets actually now are using nice, high-quality paging, and that helps improve the experience. I am totally guilty of sometimes going to one of the stores because I like the sound better, and I just would rather be there that day. So I think it's having an effect. So other places that certainly this kind of speaker fits into really well. You can cover a lot of territory from a limited number of locations. So from a designer standpoint, the state of the art at its best has been taught, or at least the literature it's been taught for manufacturers, is to use this kind of diagram to position speakers and cover long areas, whether it's a concourse or an aisle or something like that. And that is to place the reentrant or some kind of paging speaker in a very prescriptive manner, at using math that might look like this, to cover a particular area. There's a couple problems with this. One is that every one of those speakers arrives to a listener, and they all arrive at a different time. So that affects whether the music sounds clear, and it can cause a lot of difficulty for intelligibility. So for that to work right, all of those have to have individual amplifier channels so they can have a delay setting applied. And that's a valid way to work, but generally with delays and the extra cost of cabling, installing the cabling, amplification, DSP, all that's really only justified when there was no other way to get it done, right? So what happens a lot of times, these go in without delay, and you get this really odd sounding thing that might be really hard to follow and understand what's being announced. So you could be perhaps close to one of those speakers and getting a decent signal, but then you're in between them and you're getting either a drop in level or the interference of the other speakers arriving to you. Not a pleasant experience, and can be truly dysfunctional from an intelligibility standpoint. With the CCA, we had the ability to place a fewer number of devices, let them cover a lot of territory, and put more people, more listening areas, more occupants into reasonably uniform coverage. And we can use the delay method. Like I said, it's important to have that in your toolbox as a designer when you need it, right? So if your coverage, reaches its limit but doesn't quite get to the distance you need to cover, then it's appropriate to put in a delay. But you've probably gone 50 feet, 100 feet, 200 feet, maybe more like 150. I mean, you may have gone quite a distance before you need that additional speaker with the CCA. So let's look at this in modeling. If you are working with paging systems, you may not be thinking about modeling. I'm going to present some things about modeling that will probably help you with your design work. If you've been working with something like Ease Focus or Ease Address or what have you, maybe you've already explored Warehouse Designer, some of this should look familiar. Tomorrow we'll have a session just on how to walk through the modeling process step by step. So here I have 3 speakers set up in that orientation where one follows the next, right? And the coverage is basically covering from about 0 to 20 meters in here, maybe 30, 25 meters, so 75, 80 feet, with 3 devices running. And you'll see there's 3 flags there, the blue one, a green one, and a red one. The blue and the green are very similar in level in that frequency response chart. But look at the red one. That's way out there. So at that position, in order to get coverage, we have to continue placing speakers, which have accumulative costs and accumulative wiring costs. And if you're really doing it right, you did it with delays, which amplifies your costs every time you add a delay, right? So that's kind of been the way we've had to work. And that's been partly due to the limits of the technology and partly due to, I think, some limiting design methods that have been taught. So what's the new state of the art? Well, that is to put in one device that covers everything from flag 1 to 3. So a little more than twice the distance and basically get the same level. You'll see 1 and 2, or 1 and 3, the red and the blue, basically lay on each other in this display. And 4, which is actually outside of what we would call it the defined coverage area for a CCA, is still only a couple dB down in that chart. So we can cover an awful lot of territory with just one device running on 1 amp channel. And it may even share that channel with others that have the same signal processing requirement. So what is this 6-to-1 rule? What's this special asymmetrical coverage? How do I use that? This is the one way to approximate the coverage, and it works out really well. In fact, if you take what's drawn here, you go into your modeling system, you get exactly what I just showed you previously, which is where I drew that from. I actually used a model from our spec sheet to build that. So the 6-to-1 rule basically says we look at how high the CCA-80 is from the listening height. That's typically 5.5 feet or so for standing adults, 1.7 meters, right? Take that distance from the listening height to the speaker, multiply by 6. That's how far we can go. And then the width is 2.3 times that number. So real basic math. You don't have to get out your algebra book or your trig book or anything to figure that out. Very easy to follow along. And there's this little tiny area there from the speaker position to where does the coverage effectively begin. That's just a fraction of that H dimension here. You can see there it's 0.3 times H, or 0.13 times H. So just a small area there where you're not quite in the full coverage frequency-wise, all receiving everything evenly. It's a little better view of that if that's easier to see on whatever device you're using today. And for the AutoCAD users in the crowd, here's a side view basically of that coverage scenario. So those are the ratios. Pretty easy to follow. So let's do an example. We'll put in CCA here at 7.7 meters above a listening plane. So that's 6 meters above the listening plane, and see what we get. So we're basically right back to what I showed earlier, and that is take that prescription for the 6-to-1 coverage method and apply it to your modeling, and you get results like this. Now, what about the R.15? This doesn't have this new asymmetrical method. It's a conventional constant directivity horn. How do we use that well? Well, we can use that design where we march them along on a prescribed 30-degree tilts and so forth. And actually, you do that, you get too much over coverage with these, and actually with a lot of speakers. So what we're actually looking for is, where does the sound drop about 6 dB? And that's where we would need to put a supplemental speaker, add delay, and continue through a concourse. So the 3-to-1 rule is the thing I reach for quite a bit in estimating a job. Now, to really do this precisely, I get out my smartphone and get out my little trig app where I can plug in a couple pieces of information, and it gives me all the other values for a right triangle, and that's one way to work. But basically, the trim height to the first listener is a distance, whatever that is. And about 3 times that is about where the sound pressure drops off 6 dB. And that's just the inverse square law doing what it does for point source type devices. If we want to kind of chart that out, it looks kind of like this. So here's an example of a device that's up 12 units, whether that's meters or feet. And there's a distance of about 13 to where the coverage begins, right? And then the longer yellow line is the on-axis energy for the speaker aimed at the furthest listener. And so about 27 units away, whether that's feet or meters, is about where that happens. So if I was going to place another device, I would put it out there toward the, the right side of that 27 figure. So let's put that into a model and see what we get here. So the blue line here, the blue marker is that D1 position, that first distance. 3 is the D2, and then on axis actually is flag 2. So we're getting actually a little bit further than 3 to 1 with the R.15. So that's 2 ways to work pretty quickly to figure out how to place things. I'll show you some ways to speed that up. So here's some design tools. Okay. First one is made a DXF block. This will be a handout you'll get in your email today or tomorrow. And so this is something you literally can just drop these onto your plans, scale them based on the trim height of the speaker, and start placing them on your plan view. If that's the level of design and modeling that you think is appropriate for your project, you can do that. Also, we'll include a SketchUp block. It's a file with exactly the same thing for the CCA-80. The way we typically work today, in today's world for sound system design, is use some sort of modeling system. We lean on Ease Focus 3 quite a bit. It was originally designed for line sources. We use it for quite a variety of things in our catalog. It lets us do simple 2D drafting. It's very accessible to learn how to draft in it, but you're getting 3D results, and you can do complicated things with it. Very precise positioning and aiming of speakers and signal processing on the speakers in the model and so forth. And the nice thing is when you're done, it produces an automatic PDF report. So that's a great way to communicate your design to people in your design team or to an owner or as part of your presentation package and so forth. So we're fully supporting Focus 3 for both of these models. So that's available as it normally would be for any of our models that are or products that are licensed for Focus. So that's one way to work. I will say this is great when we have to solve a little bit more complicated problems. We have certain geometries about the mounting height and the boundaries in the area and so forth, and we need to study this a little bit more. This is helpful. For a paging system, if there's more than just a few devices, this is actually a real time-consuming way to get things done because you have to place every single speaker one at a time and map it and then decide if you like it and do it again. And we've proven in some projects here that something that could take, well, here's an example of one, actually took about 8 or 10 hours of effort to get it figured out for a moderately complex sort of warehouse industrial type space. We were able to cut that down to less than an hour with another piece of software you'll see in a minute. So, and actually get better intelligibility results out of it. So this doesn't let us see intelligibility, it just lets us see coverage. So keep that in mind. But there are places to get Focus open and solve problems for jobs. Another one that you might be familiar with is these kind of ceiling speaker type calculators with Ease Address and Ease Evac. Their interfaces are nearly identical. Evac lets you do some acoustic study to a limited degree, in addition to doing these overhead type grid position speaker layouts. It's nice in that you can outline your target coverage areas, and they can even be very irregular, and it will help you land speakers in that environment. Now, for address, we're licensing the R.15-3696, and so that is available to you because that could be used overhead as a pendant, right? CCA-80 is basically meant to hang and aim straight ahead. There may be some occasions to give it a slight tilt, but it's certainly not meant to be set up and aimed straight down. I can't think of many places where that would make any sense at all. So that's not included as a file for evac or ease address. And here's what that model environment looks like. It's pretty straightforward and all these little white boxes along the perimeter of that floor plan. You can easily grab them with your mouse, drag them around to create the shape you need to follow the floor plan. You can put in a background image in. You actually have the floor plan from your PDF or your CAD file. And it's a fast way to work for this kind of deployment. There are certainly places where paging systems, this is a smart way to go, particularly when you need really careful, discrete coverage of zones, and you'll be able to turn them on and off or deliver different messages to different parts of a facility. Or a place where you just don't know how things are going to be set up on the floor plan, or maybe the floor plan changes a lot. And this can be an effective way to work as a designer. Get that a lot, that they're building the big warehouse distribution type building, and they haven't decided yet where all the furniture is going to go. Where will there be racking? Where will there be material handling, workstations, and all? And so sometimes we have to resort to this method. Tends to be a higher speaker count, but sometimes this is the way to do it. All right, Warehouse Designer is a new web-based tool that's been available about a year, I guess, or a little more. It's part of the sort of the catalog of design tools that we have on Cornerstone for conference rooms, classrooms, and other scenarios. And Warehouse Designer lets us basically input information the way you would put them in these conference room, classroom calculators, and actually put in several areas to a facility all at the same time. And you can make a fairly complicated model. You can make a very simple one. But basically, you're putting in basic information, and it's giving you recommended designs. The nice thing about Warehouse Designer is you don't have to be good at drafting. You just have to be good at getting measurements, dimensions off of a floor plan and an elevation, so you know how high the roofing system is, or the mounting structure for speakers is. And then as the user, you're just telling it, this is what we're trying to accomplish in that space. This is how noisy it is. This is what kind of equipment's in there. This is what kind of furniture's in there, if you will, the racking or other equipment. And it will come up with recommended designs based on that. And then you can iterate and adjust it to your preferences. And we'll go over that in more detail tomorrow, but pretty straightforward process. I've found some people try to do a really complicated job, their first one. I don't recommend doing that. It can be a little overwhelming if you haven't done one or two. But the program starts with a video, gives you like a 5 to 10 minute introduction to how to work in Warehouse Designer. And that video lives on YouTube, and there's a longer form version that we published, I guess it was last spring or last winter, I don't remember. And so those are both there. You can go follow some instructions on how to do all the steps and some of the more complex choices that come in here. But basically, you're giving it the dimensions of areas and telling it what's going on in that area, and then it produces a recommended design, and you can adjust it, and then you get a nice report at the end that details everything you could possibly want to know about that system to build a material, whether that's going into prints or whether that's going into quotes. So everything that you need for the next step. Got one note on acoustics I do want to mention. It's sort of a limitation thing that you need to be aware of. When we have really large open spaces like this, where there's very little material placed in them or that would be placed in them, the reverberation times can get really, really long. This is an example of a space I worked in and measured a 10 or 11 second reverberation time. And so you probably already know that the longer it takes time to naturally die off and decay in a space, the harder it is to get intelligible speech or music in that environment. So in the warehouse designer, it's always reporting to you, not just what's the coverage, but what's the intelligibility results and the best available intelligibility results based on the various speakers available and all the conditions that you've indicated. Sometimes those numbers aren't as high as you'd like them to be, or that you might be required to achieve. So there's certainly occasions in rooms that look like this, where we may need to reach outside the paging and commercial catalog and grab something else that's really high directional or really high output if it's a very noisy space, and give that some additional care and feeding to get a good layout that works for those areas. So just be aware of that. All right, pay attention to both the coverage and the STI results that get mapped in Warehouse Designer. Okay. And I've kind of already mentioned the high noise, but if you have a lot of machinery or equipment that really raise the noise level above conversation level, maybe even hearing protection type levels, that is also something that Warehouse Designer will try to address, but it doesn't have some of our really high output products available to it in the catalog that it uses. Excuse me just a sec. And oops, wrong button. And so if you have an occasion where really high noise is a concern, then you probably have to reach to one of the larger R series models to address those. That's another place where we might have to go outside of Warehouse Designer and go study that a little closer in one of the other programs.